Seeing there's a lot of Rick and Morty fans out there, or maybe Spring Cloud Stream. How are you all doing? It's been a great conference so far. I want to welcome all of you to my talk about Spring Cloud Stream, a new Rick and Morty adventure. And I guess we'll dive right into it. I just want to thank Andre from Java Day Kiev, because I forgot my t-shirt there. We had special t-shirts, and he brought it to me and gave it to me yesterday, so he remembered. Thank you for that, Andre. So let's start. My name is Dieter Hubau. I'm from Belgium, and I work at a consultancy company called Ordina. It's probably not known here, it's just in the Benelux. And we work on all kinds of Spring projects. We do we contribute to Spring framework itself, and we have some open source projects, and I have contributed there a little bit myself as well. I'm working on all kinds of stuff. You can check it out on GitHub. I just want to welcome you to the Microverse. For the people who don't know Rick and Morty, you will not get a lot of the talk, but that's fine. It will still be funny. If you don't think it's funny, you don't have a sense of humor, so that's fine. So this is how Rick tells people hello. So peace among worlds. I'm not going to do the science because it's being live streamed, but this is how he welcomes the people of his planet. So let's dive into Spring Cloud Stream. The project began probably in 2015, and initially it was in its prototype phase. It was called Spring Bus, but it's kind of weird, so I guess it was a prototype name. And I think in May or July of 2015, so that's already 3 years old now, I think Dave Sire, who might be here, he'll be speaking the hour after me, he committed the first push with the name Spring Cloud Stream. So we'll call that the birth date of Spring Cloud Stream. And you all want to know what it is, right? You want to see what it means, Spring Cloud Stream. So as many Spring projects, it can be viewed or can be seen as a simple Spring Boot application, which has the concept of binders and binding implementations, and it can connect to these binders using inputs and output channels. And it will connect to these channels to existing middleware like RabbitMQ, Kafka, Redis, etc. So as I said, it's a framework for creating message-driven microservices, and we can send these messages to the middleware. It builds upon Spring Boot, so you can make Spring Cloud Stream applications really quickly and build on all the advantages that Spring Boot gives. Under the covers, it's using Spring integration. So for some of you who have used Spring integration, it can sometimes be difficult to get into. Not anymore with Spring Cloud Stream, because it takes away all the abstractions. It goes up a layer of abstraction, and it makes it much more easy for the developer. As with Spring Boot, they have a very opinionated configuration, a default configuration for you. And they configure a lot for you that you don't have to do. So that's the easy part. You don't have to write all the boilerplate code. And they provide you with a configuration up front. The most important part is that they have they are building on the pub/sub semantics. So you publish and you subscribe to channels, and they support these many middleware vendors. So Kafka and RabbitMQ are first-class support, and ActiveMQ, Redis, AWS Kinesis, they are community projects. And Google is also working on official support for Google pub/sub. So that's coming, I think, next month or in 2 months. Ray Tsang from Google had a great workshop at Spring.io about all this. They are really working on a lot of Spring Cloud starters to connect to Google services very easily. So that's coming up soon. So let's see a really basic example of a Spring Cloud Stream application. As you can see in the top, for people that know Spring Boot, it's a regular Spring Boot application. And the two annotations that you might not know yet are enable binding and stream listener. So enable binding is the most important one, because that one will set up the channels that are defined in that sync class there. He will set up the channels that are defined there. So if you do not add the enable binding annotation, you will never have a Spring Cloud Stream application. So that's the first one. And the second one is add stream listener. And it takes one of the channels in the sync class, namely the only one, it's the input channel, and it attaches it, hooks it to a method, process vote. As you can see, we're not working with message classes or all kinds of Spring Cloud, Spring integration classes. You can directly use the class that is in the payload, and Spring Cloud Stream will do the conversion for you of the message. So this is a really, really simple example. As you can see, they also have support for Flux and for a reactive programming model. So you can use all the stuff from Spring Reactor to process your messages. In this case, you can see that it's enabling the binding on a processor. So a processor is input and output, and it will automatically define a channel called input and a channel called output. So as you can see in the method, there's an input annotation, which is bound to the input channel of a flux of strings, and it returns a flux of strings which is annotated with the output channel. So this is really basic stuff. This is probably the simplest form of a processor that you can have. To continue, if you would want to bind to RabbitMQ, if people have used RabbitMQ before without using Spring Cloud Stream, you would probably have to make like a connection factory or do a lot of boilerplate code to connect to RabbitMQ, do all these kind of RabbitMQ specific stuff. But that's the fun part about Spring Cloud Stream. It abstracts away the specifics of the message broker. So you have a common programming model, and the common programming model makes sure that the implementation in the class path, in this case for RabbitMQ, gets used and does all the stuff for you. So, as in many cases with Spring Boot, all you have to do is add a starter, which is in this case the Spring Cloud starter stream Rabbit, and for example, also a web starter for exposing a controller endpoint or something. So. The only thing that you have to do when you want to go through ActiveMQ or some GMS message broker is add this property, which means that it will never use queues in GMS, but it will always use topics, because you cannot do pubs up with multiple subscribers on regular queues, right? If you want to define your own channels, which we will do in the demo, you'll see about that, you can just define your own output and input channels using the interface, using a simple interface. So that's another simple example. The web application could look like this. You have this is everything packed in one class, as Josh Long would do it probably. You have a REST controller, which is also a Spring Boot application, and you enable the binding to your own channels class. You can auto-wire the channels interface, and at runtime, Spring Cloud Stream will inject in a proxy implementation with the channel, with the output channel. So what we do here is we have a get mapping, where we just can send a request to the application. It will receive the message, and it will output it to the output channel. And in the same application, we will receive this output and print it out. So we can create this quite quickly. Let me just try that out real quickly. So whatever we do with Spring Boot, we go to start.spring.io, and we just say, I want web, and I want cloud stream. That's the one. And we don't want rabbit, right? So we generate a project. Where is it in my downloads? Let me go there, and we'll go to demo 4. Demo \4. Come on. Oh, I'm already there. Like this. Still in Windows mode. I'll open the project. Hopefully. It was in. Where's the downloads? Come on. What the? Okay, let me just. Why won't it open a new window for me? And why don't I have? Let me just move it. There we go. And we have the setup of the project. Has to download all the dependencies, but I should have them already. And we have this one class, as you know, in Spring Boot applications. And we'll just add REST controller. And what was the other one? Enable binding to my. I'll just do the output. So when we want to Spring Cloud Stream source, we define the source class, and we just create a simple. We'll do a get mapping. With a message. No, not that one. No. We'll do just message. I'll figure it out. And I'll have to make my own channel. And we'll define the output channel. And then we can auto wire it, and then this send, and then I think you have some kind of message builder, right? In build. And then when we can listen to it, to the I'll call it output, so that's the name of my channel. Should be like this. and I'll just print it out. Yeah, like this. And we have to, of course, make a post mapping. Yeah. And he's complaining about the auto wiring. That's the only thing in IntelliJ. IntelliJ doesn't know yet that it's an interface because it's not annotated as a bean or anything. But you can see here that he knows it's part of a Spring Cloud stream. It will create a bean at runtime, so it's not defined as a bean yet. And the annoying part is also that IntelliJ always says that this channel is not used. Okay. And then you should be able to just run it. Yeah, he's still complaining. Run it. Where's the output? Yeah. I don't think it can be static. That was not. Usually you put just the channel definition in another class, a separate class. Yeah, now it's going cyclic dependency. I'll just move it out. The thing is, I'd only have 45 minutes, so I'll go to the big demo in a bit. First, I'll explain the other stuff. So that's a really basic example of how you can consume your own message, which is really pointless. So let's talk about some of the advantages of Spring Cloud Stream. And the advantages of the pub/sub style communication. It means that, for example, when you have some kind of source, maybe an HTTP source, sending sensor data, I don't know, temperature data, humidity data from an IoT device or something, and it's sending this through an HTTP connection to a topic. And the topic is called raw sensor data. And as you can see, there are two subscribers on that raw sensor data topic called averages and ingest HDFS. So maybe the ingest will just save all this data on HDFS, and the other one is a separate application and will calculate all the averages of these input data. He will send out. So it's a processor. Averages is a processor because it has input and output, and it will send it to the averages topic. The averages topic will send it to will be consumed by the top N application, and the top N application will output it to another topic which is called hottest. So it will take the hottest temperature or something, or the hottest item in the list. The cool thing is that this kind of architecture allows you to just add a new application called maybe fault detection to consume the same topic averages. So it can take the averages and somehow figure out what are the anomalies and take out the faults. And all the other applications would not be affected. That's the cool part about it. The other applications don't even have to know about it. So if you work with this pub/sub style, you make your architecture very dynamic and very flexible. So all the data is shared is broadcast through shared topics. It reduces the complexity because the consumer or the producer does not have to know about the consumer, and new consumers can be easily added afterwards. So you reduce the coupling. So if you are building lots of microservices and you work with this kind of communication, you don't have to know about each other, so you reduce all the coupling between the services. Another cool thing is the consumer groups feature. So consumer groups is something that comes from Kafka. For the people that know Kafka, this will be very familiar. So they have the concept of consumer groups, but they with the layer of abstraction, they can also have the feature of consumer groups for RabbitMQ, for example. So the binder implementation of the message of the middleware will have to implement this feature for it to be Spring Cloud Stream compliant, right? So the thing about consumer groups is that you can have multiple instances of a microservice that consumes that one data source. So for example, if you have an average calculator and it's having a very high workload, you can just scale up and have more instances, and average calculator 1 and average calculator 2 will split the load. So they will only take one message each. They will not take the same messages. If you want another consumer group to also take all the data, you could have HDFS write 1 and HDFS write 2. So they will also split the work between them. So they are basically parts of consumer groups. So this is similar. All the groups subscribe to a given destination, and they all receive a copy. Each consumer group receives a copy of all the data. Only one member actually processes the message. So this is important. If you scale out an application and you want each instance to receive all the messages, do not use consumer groups then. They have to be in their own anonymous group then. As you can see here, the default behavior is that each instance is anonymous single-member consumer group. So if I don't specify a group, average calculator 1 and average calculator 2 will be separate groups, anonymous groups, and they will receive all the messages. So that's an important distinction. So I guess most of you are here to have the fun stuff about Rick and Morty. So we'll just move to the use case. And the use case, if anyone have seen it, is about a Szechuan sauce. And it's really important because Rick really wants that Szechuan sauce.
Where are we going?
To the day it all began, and in...
Buffering.
The moment that changed everything.
Welcome to McDonald's. Can I take your order?
Yeah, I'd like to get a 10-piece McNugget and a bunch of the Szechuan sauce, like as much as you're allowed to give me.
Look at the commercial.
In 1998, they had this promotion for the Disney film Mulan, where they created a new sauce for the McNuggets called Szechuan sauce, and it's delicious. And then they got rid of it, and now it's gone. This is the only place we're gonna be able to try it. It's in my memory.
Rick, you're doing this bit while your brain is melting.
Okay, all right.
Okay. So it's very important. We need to get that Szechuan sauce. Not this one. This one, yeah. So let's introduce Rick. He's a genius, he's a professor, and he's a bit of an asshole. And he's the grandpa of Morty, which we'll see later. He's the inventor of the Microverse, which is also important, remember that. He can do interdimensional travel. He created the butter passing robot. And he wants more Szechuan sauce. But he doesn't want to do it himself. He wants to pass it on to a friend of his. So we have created, or I have created, a Rick microservice, which will send messages to RabbitMQ. And he will send messages increasingly faster, saying, I want my Szechuan sauce. So he can consume from the queue to know if the Szechuan sauce has been found. He will listen on the input channel Rick, and he will send out his request for the Szechuan sauce to an output channel called Microverse. So we will define two channels where he will send messages to, send and receive. So as you can see here, quite small probably, I'll make it bigger. It's a simple Spring Boot application with enable binding. That's the most important part to make it a Spring Cloud Stream application. And it's Rick channels. So let's go there. As you can see, it's quite simple. It defines 3 channels. Oh, I probably forgot about the most important one, right? This one, Meeseeks. So he's also sending to Meeseeks. You'll see who that is later. And so this corresponds to that image, 1 input channel, 2 output channels. Quite simple, right? The input channel is a subscribable channel, which means you can subscribe on it. And we'll see how that happens, well, now. Let me just open the Szechuan Finder. So this is a bit more boilerplate code just to send some messages. But as you can see, we auto-wire the Rick channels, and we are listening on the input channel Rick. And only if the message is all done, we will send a message wubba-lubba-dub-dub. So you'll see that at the end of the demo, hopefully. Most importantly, when we send a GET request to Rick, he will wake up and start finding that sauce. So this is some really, really professional code with a while loop. So as long as he's searching is true, he'll keep sending messages to Meeseeks saying like, I really want my Szechuan sauce. And he will sleep in an interval, and the interval gets smaller as we go. So he will keep sending faster and faster and faster until it's probably the minimum interval is like 15 milliseconds. So at his fastest, he will be sending 20 messages a second. And so Meeseeks will have work to do. So
this is a Meeseeks box. Let me show you how it works. You press this.
I'm Mr. Meeseeks! Look at me!
You make a request. Mr. Meeseeks, open Jerry's stupid mayonnaise jar.
Yes, sirree!
The Meeseeks fulfills the request.
All done!
Wow. And then it stops existing.
Oh my God, he exploded.
Trust me, they're fine.
They're fine with it. They're fine with it. So, Mr. Meeseeks was invented by Rick. He is summoned by the Meeseeks box. So when I did this demo at Devox, we had a booth at Devox, and we had this demo set up. We actually had a 3D box, 3D printed, and we put a Raspberry Pi inside with a big button, and people could slam the button, and then Mr. Meeseeks would be scaled up to 1 or 2 or 3. So that was quite fun. By the way, don't order the 3D printed box in millimeters. Order them in centimeters, because first time we received this really tiny box. That was not cool. As you know, magical creature, he's spawned for a single purpose. And once his task is complete, he should disappear. So in our application, when we run it on the cloud, he should scale back to 0. Sorry. So, Meeseeks, it's the same kind of microservice. It's set up exactly the same way. And he subscribes to the Meeseeks channel, and he outputs to the Microverse and to Rick when he's done finding it. And he also sends to McDonald's, because he's going to want that Szechuan sauce. I'll show you in a bit the code. Let's continue with the use case. McDonald's, very simple Spring Cloud Stream application. It doesn't even have the web dependency, so no REST controller or anything, just the Spring Cloud Stream. And it receives messages in the input channel called McDonald's, and it sends back to it sends its output back to Meeseeks. Morty is like the perfect sidekick. It's also like the pretty face of the show. So Morty is going to be our front end, written in really quickly, written in Vue.js and Bulma. It's like some kind of Bootstrap clone, but better. And it is listening on all the output channels. So for him, these are input channels. So this is my grand architecture with RabbitQ in the middle. It seems like a service bus, doesn't it? But the thing is that this is actually scalable. And as you can see on the bottom right, we also have a Meeseeks box, which can scale up or down the Meeseeks in the cloud. So, time for action. Let's see what we can do in this application. I'll go away. I'll start up these applications. So I think McDonald's application and the Meeseeks application, they don't even have the web dependency. It's one of the cool new features in Spring Cloud Stream 2. You don't need the web dependency. You can just do Spring Cloud Stream and RabbitMQ. So it's quite a small footprint. Okay, so they have all started up. Probably Mr. Meeseeks is already sending all kinds of messages. Let me check here. Let's go to Morty, see what Morty has to show. So this is really basic. My front-end skills suck. So I don't know if there's going to be sound, but there should be whenever Mr. Meeseeks says something.
I'm Mr. Meeseeks, look at me!
So that's Mr. Meeseeks.
I'm Mr. Meeseeks, look at me!
Okay, I'm going to turn this off for a while. He'll just keep saying that until he dies, because he's a Meeseeks and he really wants to die. Existence is pain, as you can see. And we'll just start by waking up Rick. So we'll send a GET request to localhost 8080 where Rick lives, and he should start sending messages. So this is just running locally. I have a local RabbitMQ running on Docker, and it's going to keep sending messages. I'm afraid to turn on the sound because we'll do the demo in a bit with everyone on in the cloud, and you'll have enough sound then. So this will keep going faster and faster. Let's check out. RabbitMQ. So you can see the messages going up. There's a queue here. There's some exchanges with all the channels. These are the RabbitMQ channels, so that's not the same thing. But if you look at the overview, you'll see him going up and up. In the cloud, sometimes I forgot that the demo was running, and there was something wrong with the Meeseeks. So Rick kept on spamming 50 messages a second for like 3 months. So I forgot about it. So there were 6 or 7, 70 million messages on the queue and a couple of gigabytes. So purging that queue was really took a long time. So don't forget about your Meeseeks. As you can see, it's going up a lot. Maybe he already found it. There's like a 1 in 1,000 chance that he says you have found the Szechuan sauce. So it keeps on going and going on the top left. I think usually on average it's about 2,000 or something. We're sending all this to the browser using event streams. That's some really fun code. I'll just let this going, and we can do the big demo with everyone in a bit. But yeah, this one really spamming lots of messages. I'll show the controller here. So what we do in the front end, so this is a REST controller in Morty, so in the front end, and well, in the back end of the front end. And we just, in the HTML, we just subscribe to an event stream /events. So that's this one. And if we do a get, HTTP get to that endpoint, we receive back an SSE emitter, which is a service sent event emitter. And we add it to the list of emitters. And when we get a message from any of the output channels, we just handle the glip glop. If you don't know what glip glops are, you should look it up and see the corresponding video. It's quite nasty. And we just send the message to all emitters. So if there's 20 people looking at the application, they will all receive these 50 messages per second or more. So it's quite a lot of messages, and it works quite well, in my opinion. So we're using a parallel stream to just use a couple of threads to send them. So I just changed that code yesterday. So I hope if 20 or more people are looking at the application, that it will still work. So let's see if we found it already. Come on. Okay, so he found it after 6,000 messages, finally. So at the end, he says wubba-lubba-dub-dub, and Meeseeks just, it's not in the cloud, so it cannot scale down to 0 until I like really kill the process. So it just keeps living and exists in this brain. And the McDonald said, you're a winner. So that's finished. So what happens if we try this out on the cloud? So anyone, if you have internet, if you want, you can go to RNM. Maybe you probably can't read it, and I don't know how to zoom in, but RNM from Rick and Morty -Morty dot cfapps.io. So CF Apps is Cloud Foundry apps. It's running on Pivotal Cloud Foundry on the free version. Well, not the free version, but the as a service version. And if you can find it's RNM from Rick and Morty -Morty.cfapps.io. So what we'll do first is we'll spawn. I'll turn on the sound this time.
I just want to die! We all want to die! We're Meeseeks! Why did you even rope me into this? Because he roped me into this! Well, him over there, he roped me into this!
My local one was still running. I was wondering where that came from. We'll just spawn a Meeseeks. Well, anyone can push the button. Just push the middle image. If someone can, if you find the website. Normally it should spawn a Meeseeks. Not working? Wait. Let me just go to, let me just go to Pivotal Web Services. It was working fine this morning. You can't click 20,000 times. It's almost there. There we go. Sign in. Keep clicking. It's going quite slowly, but it'll be fine.
I'm not driven by avenging my...
None of the messages are coming in.
Dead family, Morty. That was fake.
Maybe it's the Wi-Fi. I'll just blame it on the Wi-Fi, as always. Let me see here. Come on. Yeah, so there should be... Oh, maybe Morty is failing. Oh, no, he's doing fine. Let's scale up Morty. Because there's infinite dimensions, we can have infinite Mortys, so... It's taking quite a while. So there's 2 new instances starting from Morty. There's already 3 Meeseeks, so the scaling up worked. He was at 0 Meeseeks, and now he's at 3. So let me check. Maybe we have a service here in the cloud called a Cloud AMQ as a service, and I have the Big Bunny plan, so the Big Bunny should be able to handle it. Let me just see in the Cloud RabbitMQ where all the messages are going. I can see. Should I refresh? Is it working now? Okay. Do you have sound? There's someone where it's working. I heard a wubba-lubba-dub-dub already somewhere, so.
Mr. Meeseeks,
There we go.
look at me. Mr. Meeseeks, look at me.
I'll just put it a little bit
Mr.
quieter.
Meeseeks, look at me.
Oh yeah, there's many messages coming in now. So there's some delay, maybe because of the network, but
Look at me.
there's a lot of people here with
Mr. Meeseeks, look at me!
Lubba-dub-dub.
if you keep clicking on the middle message, she will keep trying to spawn Meeseeks, but it won't. It's like a maximum of 3. I don't have infinite money.
Mr. Meeseeks, look at me! Mr. Meeseeks, look at me! Mr. Meeseeks, look at me!
I think probably a lot of people are clicking right now, so that
Mr. Meeseeks, look at me!
maybe we'll go to the local version again. But you can try it out anytime. You see, yeah, this site is not even loading, so I'll just keep running locally. And I want to show you some other stuff, which is new in Spring Cloud Stream 2. So recently, Spring Boot 2 came out. And we had a big party at Ordina. We invited Stefan Nicole from Spring. He's a Belgian as well. And he came and we made him this nice cake. So a little bit after that, Spring Cloud Stream 2.0 came out as well. And there's some new features which are quite cool. So I'm going to go over them. You can now use polled consumers and just consume messages whenever you feel like it. There's a new class called pollable message source, and on this message source you can just say poll, and if there's a message you'll get it. If not, he won't do anything. So there's some examples online in documentation, which is really extensive. It's a good documentation, as always with Spring, and you should have a look at that. Also, there's micrometer support, and I really want to show this. Micrometer is like the easiest way to explain. It's like SLF4J, but for metrics. So it's a common API, and you can have different kinds of implementations or registries, as they call it. So you can send your your metrics to Prometheus, for example. So I made a little small example of that. If I go to my application, my console here. And if I do Docker compose up, it should create Grafana and Prometheus for me. Yes. And now we should be able to go to the Grafana frontend. Log in. We can add a data source, which is just Prometheus, and it's a direct to localhost 9090. Data source is now working. We have a Prometheus data source, and we can add a dashboard or import a dashboard. And I'll just take an existing one. So this is the cool thing. You can just go to the website and look for dashboards that interest you. There's a Java micrometer basics for Spring Boot application. So you can just paste the ID. You select the Prometheus data source, and you have a dashboard. So if I look at my applications, are they still running? My applications are still running, but probably it took a while. Prometheus still has to collect some data. But now we can add, there's no predefined dashboards for all the Spring Cloud Stream metrics yet. So we'll have a look what they look like. Normally there should be some stuff running here. So this is also quite cool. Come on. So if you go to, if you expose all the endpoints, if you know about the actuator endpoints, there has been some changes. You have to enable them now because they are disabled by default. But if you enable the actuator bindings, so this shows all the bindings that you have to the channels. So we have the Microverse channel with a lot of information. We have the Rick channel. We have McDonald's, and we have Meeseeks. So this is some information about the current bindings. And if you enable the micrometer or micrometer Prometheus registry, so it's just a matter of adding one dependency, and then you can see a lot of metrics about all kinds of RabbitMQ connections, Tomcat stuff, but normally you should also have Spring integration stuff. So you can see all kind of stuff here with the success rates and the failure rates. And if you look for that in the Grafana, there are no data points yet. That's a bit weird. Oh yeah, I should. No, it should be fine. If I go to Prometheus. Come on. I should have some targets here. Maybe my IP changed. Oh, that's annoying. Wait, just quickly. Just check my IP, which is this one, I think. And I'll cancel this. And I'll change my configuration in here, which is my Prometheus file. Because Prometheus is running inside Docker and it cannot go to this IP, so you have to give your host IP. And normally I should be able to do Docker up now. There we go. And we can just log in again. Import the same dashboard. I was here. There we go. Okay. I have to add the data source from Prometheus direct localhost. There we go. And import to dashboard, use the Prometheus data source. There we go, finally. So Prometheus was already taking in info from the all the Java processes. And we can now add a panel. We will add a graph. And then we can edit the graph. And we can start typing here. So these are the Spring integration metrics. I can zoom in a bit. And I think it's the count that I need to do. And I need to do the count of where the result is success. Like that. And then you'll have on the top right, there's the count of the messages that were successful. So if I go back, you can do the same thing. You have a panel. So it's quite easily to make dashboards and see the messages flowing. So if I go to my local host, I'll turn off the sound. And if I click here or I start looking for, oh yeah, it's going to the cloud. So I just need to do like a small get and it will start looking for the Szechuan sauce. You should be able to see the metrics going up with the messages. So the successful messages will go up. I'll leave this running for a while, and I have like one more thing to say, which is, okay, the actual binding controls you have seen. You can look at all the bindings that exist, and you can also control them. You can stop channels and restart channels, so you can break the connections and reconnect them. And this is something I already said as well. The actuator endpoints and web dependencies are no longer required. They are fully optional. So you don't even need this, and you can just run it as a process. So without any HTTP access even. So I think that's probably about it. This one should start going up. So this count is the total count of messages. So that's already quite a lot. 6,000, because they exposed the endpoints from before the demo, you know. The services have been running continuously. So you just start counting. You can use the data to split up hourly, seconds, monthly, weekly, whatever. You can do anything with Prometheus, but the metrics are there. So I think after that, that concludes my talk. Thank you very much. I think we went a little bit over time, so maybe a minute for questions if there are any. Just raise your hand and we can answer your questions. Spring Security integration is, I think, role-based access on the messages, if that's what you mean or something. But if you want to do Spring Security on the web part, it's a matter of doing it as usual in a regular application. If you want to do Spring Security on messages, I think you'll have to do that yourself. You can use, you can split stream listeners between headers, so you can check the headers of the message and route them to the different handlers. So there's many options. The documentation is quite extensive. I don't think I've gone through the whole thing. I don't think they specify anything about security, so I guess it's up to you for that. So yeah, there are many options to distinguish messages from each other.